Hello everybody, and welcome to another Algebra 1 review lesson, this one on solving systems of 2x2 equations. So we've been doing these Algebra 1 reviews, and this one now is going to be looking at the 2x2 equations. That way we're prepared and ready for the 3x3 equations coming up soon. So here we get to a little cartoon of our day. So this is a little oops. Lady coming down here with all those firefighters, they're catching her. Then she goes into another burning building. Alright, so 2x2 systems. Here we go. Systems of solving equations. So a system of linear equations here. It's going to be a set of two or more linear equations. That's a system. System is two or more linear equations in the same variables. So that would be x and y. So here's an example of that. Two equations, two linear equations here. So a solution of a system of linear equations is basically the ordered pair that is the solution to each system. So basically I always say that the solution to this is, if we were to graph these, and we can see it right here, it's where x marks the spot. So it is this common solution here where both are going through the same point. So it's a common solution of each one. So it's an ordered pair that is a solution of each equation in the system. So if we were to graph these, that's what they're doing here. They're solving it by graphing. They're graphing each of these two lines. And they would probably first change them to y equals mx plus b, so that way they can identify the y-intercept and be able to get the slope. And they're noticing that this point is where the x marks the spot. They can check that point 1, 2 and into both equations and just make sure that it is a solution. 5 equals 5 here, so it works on that one. -1 equals -1, so it works on that one. So that's what we want to do on our problem on this page. We're going to do it at the bottom there. We're going to try one where we're going to solve this system, and they're already set up to where they're in y equals mx plus b, so it's even just a little bit easier. So we want to graph each one of these and then see where x marks the spot. And so as we do that, we want to first identify the starting point for the first one. So we have equation 1 and equation 2. I'll just do that here. Two equations. On equation 1, our starting point is the -3. So for -3, it's going to go down 3 right here. Let's put a point there. And then our slope is 1. That means your rise over run is up 1 and right 1. So we can say, okay, there's your point. Now we could draw the graph through that, but what I would suggest is keep doing that slope here so you can get a few more points on this one, up 1 and right 1 and so on. And then let's do the same thing for this other line. We're going to start with the y-intercept here of 1, so it's going to be up here at +1. So we'll put that one down there first. -1 is the slope, which means we're going to go down 1 and right 1. So that would be our point there. Again, we can draw our line, but if we go down 1 and right 1 again, there's the one where it's the common point. So that's our point, our solution point. So we can see, okay, this line would be drawn through here. So I'll draw that one. You go ahead and draw yours on your paper. And then the first one, I'll go ahead and draw this one now. This one went up through here. Put arrows on each end, and so we can see that common point, which would be the point 2, -1. So 2, -1. That's our common point. We can plug that in now to see if that's right. So in equation 1, we said, okay, y is -1, so -1 equals 2 minus 3, and 2 minus 3 does equal -1, so that does work there. And in equation 2, we get -1 again for y, and it's going to be negative times 2, so it'll be -2 plus 1. If I take 1 away from -2, that's also going to be -1. So that works on that one as well. So that definitely verifies that that was the solution of our system. Okay, so now that's not the only way that you can, solve a system. You don't always have to graph the two lines. Sometimes graphing the lines can be very kind of difficult if they're hard lines to graph, especially if you're, the point is not going to be a nice, easy number to figure out. So there's other ways we can solve a system. There's two other ways. The first way we'll talk about here is by substitution. So we can see we're going to use substitution to solve that. It says solve one of the equations for one of the variables. So you could solve for y, or you could even solve for x. It wouldn't matter. And then substitute the expression from step 1 into the other equation and solve for the other variable. So you find out what one variable equals, and then you substitute the value from step 2 that you just got into the one of the original equations that has both variables in it, and you solve for the other variable. And so you can see this was, here's one right here that we can look at. So we have x minus y equals -1, and we could go ahead and solve for x on this one, in fact. So they solve for x by adding y to both sides. So x equals y minus 1. So they're going to substitute this right here into this equation over here. So here's our other equation. The second equation would be this one, x plus 2y equals 5. So this would be our system. Here's equation 1 on this one. This would be equation 2 here. So they're getting one of the variables solved. That's step number 1. They got x solved, and now x equals this expression. They're going to put that expression in for x in this equation, the second equation. And now it just has y in it, so now they're going to solve for y. They figure out, okay, y equals 2 when they solve this. And now they go back to the original equation. They're going to choose this first one. They could do either one, but this one looks maybe a little easier, perhaps. They're going to take the 2 now and substitute it in for y right there. So that's where that's going. And now they can solve for x by just adding 2 to both sides, and they found x. And so that gives them their ordered pair, their x, and so their answer for x is there, their answer for y was there. Let's go ahead and try a couple here of our own. So on this one, we see one of the equations is already solved for y, so we already have an expression to substitute in. So this would be equation 1, equation 2. So we're going to substitute this equation here right in for the y right there that's in the second equation. So we'll start off with a 6x, and then we'll have a minus 5, and it's going to be times. That's why I put this in parentheses. So we're going to replace the y with this parenthesis here of negative 2x minus 9, and it's equaling the negative 19. Now we just go ahead and solve this equation for x. So we're going to have a distributive property. So we'll see 6x still there. Negative 5 times negative 2 is positive 10x. And then negative 5 times negative 9 is positive 45. And it equals negative 19. And we have to combine like terms with our x's. That's a 16x plus 45 equals negative 19. Subtract our 45 from both sides. So we have a 16x now is equal. This will add up because they're both negative. So this is going to be 64. And then we're going to divide by 16. So 64 divided by 16 tells us what x equals. That's going to be 4. 4 times 16 is 64. So x equals 4. So now we're going to take this number. We're going to go back into one of these two equations. And this one, the top one is probably the easier one. I'll do it here in blue. So we're going to now solve for y. So y equals negative 2. Instead of x, we're now going to replace it with the number we found for x, which is 4. And then minus the 9. And so now we're going to see that's negative 8, so y is equal to negative 8 minus 9, which makes negative 17. So y equals negative 17. So here's our answer. We're going to put it as an ordered pair. First one would be x, then the y answer. So there's the ordered pair. That's the ordered pair point where these two lines, if we were to graph them, would intersect. They're going to meet at that point. All right. Go ahead and pause the video now, and I'll have you try this one. You will want to let's go ahead and I'll show you which one to solve for. Let's go ahead and solve for y. We're going to add x to both sides on this one. Let's do that first. That way you have the same thing. So it'll be a y equals an x plus a 3. So that's our equation 1 now, and there's equation 2. So go ahead and pause the video and try to solve this one using the substitution method. And then go ahead and play it and see how you did. Okay, hopefully you did solve this, and you can maybe just speed through and see if you get the answer correctly. Basically what you want to do there is we're going to substitute for y, so let's say a 3x plus, instead of y, we're going to put in here, I'll put it in the parenthesis, even though we don't really need the parenthesis, equals 3. Oops, it's not equal to 3. What did I do wrong? I used the number from the top equation and I'm really putting it into the bottom equation. So I did that, made that mistake. Good thing I caught it though quickly enough. That could be an easy mistake to make. It's really supposed to be -1 there. So now we're going to combine like terms here. We'll see a 4x plus a 3 equal to -1, and we'll subtract 3 right there. And so 4x is equal now to -4, which we could see x is going to be a -1. Divided by 4, -1. So we found the x answer. Plug it back into the equation up here. Let's just go to the top one. Y equals x plus 3. That's an easy one to do. So y is equal to -1 for x plus 3. So that's easy to see that y is equal to +2. So our answer for this one, x is -1, y is 2. Hopefully you get that one correct. All right, let's move on to the next method on how to solve these, which is called the elimination method. So it says solve by elimination. So here's our elimination method. So we don't need to solve for anything on this one. We're actually going to combine the two equations together. It says here, first step number 1, multiply, if necessary, one or both equations by a constant so that at least one pair of like terms has the same or opposite coefficients. And then what you want to do, once you have your opposites, then you're going to go ahead and add or subtract the equations to eliminate one of the variables. Usually I just add them together. You combine the like terms in that case. As long as you do the opposite, if they're opposite signs, then you can just go ahead and combine them with adding. And then once you do that, you'll solve the resulting equation. You should only have one variable left at that point. And then this last step is the same last step as our substitution one. We take that answer we got, we substitute it back in to find the other variable. So here's now, I think it's going to use the same equation I think they did before. So we have the two equations are here. Here's our equation 1, equation 2, and let's see, they don't quite have the exact opposites. They do have the same variable x here. So what I would probably do is I'd probably, instead of doing what they did here, they multiply by 2. You could also multiply these by a -1, change all the signs, get rid of the x. That's another thing you could do. What they did though is they multiplied this second equation here by 2. That way they got a 2y right here and a 2y here, and they're opposite signs. So they can cancel those y terms out, and so that leaves them with just combining these together, getting 3x, combining over here, getting 3, and so now they can see x equals 1 from that. So they found their first variable, and then they're going to go and plug that back into one of the equations. They're choosing the second equation to do that too. So they're plugging it over here. So this is 1 right here. Now you're just going to go ahead and, so they could subtract 1, change both signs though. This y's got to be 2 in order for this to work out correctly. So there's our ordered pair point, 1, 2. Let's go ahead and try one of our own now. So we have 2 here to try. Solve by elimination, it says. So for this first one, it is already set up. You could see these two, we don't have to multiply anything. We already have these two set up where we can now just go ahead and add these together or combine like terms. And so that way these are going to be the ones that are going to cross out, the 2y's and -2y. So we combine the x's, that's a 6x. Combine over here, it's going to give us 0 because that's going to cross out. So this means x equals 0. So now we go back into one of these equations. It doesn't matter which one. We have equation 1 and equation 2. Let's just go from equation 1 here. So we'll say 3 times x is 3 times 0. And plus the 2y equal to the 4. So that's going to make this 0, so that just basically goes away. So now we just have this 2y equals 4. We could divide by 2 to solve that. So y is going to equal 2 on this one. So our answer for this one, the ordered pair, and you always want to write your answer as an ordered pair, x is 0 and y is 2. So that would be our answer on that problem. That's, again, the answer means this is the point of intersection that these two lines would make if you were to graph these or see these on a graph. Alright, go ahead and we're going to pause the video on this one and go ahead and try this. You could first, I would start by getting these to be opposites. You might want to cancel the y's out here. You can multiply the top one by 2. That way you get this to be a -6, or you could multiply the bottom by a -2 to get this to become a +10. Honestly, I'd probably do this one by, so you go ahead and multiply this top one by 2, and that would increase everything there. And then you can go ahead and, I would write it down below here. So you have your original equation 1, but you're going to have a new equation 1 below. So just multiply everything there by 2, and then write the new equation down here, and then go ahead and cancel out your y's and continue to solve. So go ahead and pause the video, do that problem, and then check your answer. Alright, so hopefully you did get an answer for this. An ordered pair answer is what you're looking for. So we're going to see we get negative 20x and then positive 6y is equal to 2. When I multiply the distribute, we're going to basically distribute this 2 to every term on the inside. Whoops, that didn't go quite as far as I wanted it to go to that 1. And that's supposed to go to the 3y right there. So here we go with canceling out the 6y's because they're opposites of each other. You're trying to get opposites there. You want these two to be the opposite, or one of these two pairs to be the opposite. Either going to cancel out the y's or the x's. We chose to do the y's on this one. So when we do this now, it's going to give us 25x, and over here it's going to equal 25, and so we can see that x is going to equal negative 1 if I divide by negative 25. So if x is 1, we go back into one of our equations. Just pick whichever one you want to. I'll go ahead and pick equation 2 here to do this with. So on equation 2, we got negative 5 times the x, so negative 5 times negative 1, minus 6y is equal to 23. So it's going to give us a positive 5 there, minus 6y equal to 23. Subtract the 5, and so it's going to use negative 6y is equal to 18. And then divide by negative 6. And so our y for this one is going to be 18 divided by negative 6, which is negative 3. So your ordered pair for this problem, the answer here should be x is negative 1 and y is negative 3. And that's what we want to have as our answer on that one. Okay, so again, there's 3 ways you can solve a system of equations, as we just saw. So to quickly recap, we could graph the 2 equations. That's one way. If they're in the graphable form, like y equals mx plus b, then that's not too hard to do. But if they're not in the graphable form, like these ones are not, these are kind of more set up for the elimination method. So this is another way you could do it with the elimination method. If everything is kind of lined up, your x's are lined up, y's are lined up, equal signs, numbers on the other side, that's kind of set up for the elimination method. But if you have one of the equations solved for one of the variables, then it's kind of set up for substitution method. And you can go ahead and use that method if that's the case. Now there's one last part here, or actually 2 more parts I guess to this lesson. One where we get some special solutions, but before we do that, let's go ahead and do our joke of the day. Here it is. What do you call a boomerang that doesn't come back? A boomerang that doesn't come back, that's a stick. You call it a stick. Boomerangs are usually made of wood. All right. So solving special systems of linear equations. There's 3 of these. We could get one solution that we've already seen. Okay, so that's not the special one necessarily. That's the ones we've already seen. One point of intersection right there. The lines intersect, so that point of intersection is the one solution that we would get. But there's also these other 2, and these are the more special ones. You could get no solution, which is if the lines were parallel, and that's if they have the same slope. If their slope is the same, they're going to be parallel lines. The y-intercepts are different, as you can see, but they're the same exact slope. So they're never going to touch, they're never going to intersect, so that means there's never going to be a solution. Then there's this one which just shows you one line. There's really 2 equations on this. If the lines are exactly the same, so it's like one right on top of the other line, the lines are the same, the equations would be exactly the same, they have the same slope, same y-intercept, so that means they're the same line. The answer would be infinitely many solutions then. So as we're kind of going through, as you're kind of working this out, if you do the graphs, you can see them. If it's the parallel lines, for sure, no solution. If it's the same line, it's infinitely many. But if you're doing the elimination method or even the substitution method, and you eventually get rid of your variables, you cancel out your variables, then you know it's one of these 2 options. And you got to see, okay, when you do cancel out your variables, does one side of the equal sign equal the other one? So basically when you have the one number here on this side equal to the other number, if it's not equal, if this number is not equal to that number, then it's a no solution. But if this number here is equal to the number on the other side, if they're exactly the same, then it's the infinitely many solutions. That's if you're solving by elimination or substitution. All right, let's go ahead and take a look at some examples for these. So here's one where it shows, okay, you can do method 1, you can graph them. So that's what they're showing on this one. They're graphing, they're both in y equals mx plus b. They see there's the same slope right there, different y-intercepts. So from that, even just by looking at the line or the equations here, I know that this is going to be a no solution answer. These are going to be parallel lines. And the graph definitely verifies that when we graph it and see that they are parallel lines. So this one says solve by substitution. Now substitution, if we were to do this, even though we can take a look at this and say, okay, I already know that this is, it's the same one over here. I already know this is going to be no solution. But if you were doing it by substitution, what you could do here is you could say, okay, they both equal y, so they both equal each other. Go ahead and write this down. You can say this one equals this one and see what happens here. We're going to be subtracting 2x from both sides to try to get the x's together, but we're going to cancel out the x's. Now we have no x's. What we have left on this side is a 1, and on this side it's a -5. And of course 1 does not equal -5. So again, this number does not equal that number, so the answer there would be the no solution answer. Okay, let's take a look at another example. This one having infinitely many, so here's the equation. So this one, if they did graph it, they're showing the graph is the same exact line, even though these don't look like the same exact equation. You could get them to become the same equation, though, if you were to solve it for y. If we solve both of these for y, they would end up being exactly the same equation. So like if I did this, if I added 2x over there, the first one will become y equals 2x, positive 2x plus 3. If I was to add 4x here first, like this, adding 4x to both sides, then divide by 2, I'm going to get y equals 4x divided by 2 would be 2x, and 6 divided by 2 would be 3. See, it's exactly the same thing. And so that's one way you could do it. You could just always get it to this way, solve it for y, and see, if you have the same slope and different numbers here, they're no solution. If you have the same slope and the same number, it is the infinitely many. So obviously by graphing it, you can figure that out. Another way you could do it, though, is by the elimination method. So if we were to try to eliminate one of the variables here, let's go ahead and try to eliminate the y's on this one, which means I would need to multiply the top here by -2 to be opposite of positive 2. So that's going to give me a positive 4x, a -2y, and it's going to equal -6 on the other side. So now I have these two equations. As I combine them, I'm going to see, well, I'm going to cancel out my x terms. I'm also going to cancel out my y terms, and I'm also going to cancel out my 6's. So I have nothing over here, it's just 0, and I have nothing over here, it's also 0, and definitely 0 equals 0. So since this is the same number on each side, 0 is the same on both sides, this would be the infinitely many solutions. So we'd say infinitely many solutions for this answer. Alright, so that's kind of showing you what you would do for these special ones. If you get this situation, you know what to write. Sometimes you might get a no solution answer, sometimes an infinitely many solutions answer. Okay, so our last part here is solving some real life problems. We usually have, with systems of equations, some word problems, some real life problems and situations that we can use systems of equations to help us solve them. So the first thing we got to do is obviously read through our problem and kind of decipher and maybe try to understand what it's asking us to do. It's going to tell us right down here to write something. It's going to say write a system of linear equations. So it tells you you're going to use system of equations to do this. So it says a drama club earns $1,040 from a production. A total of 64 adult tickets and 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. So we're going to write a system of linear equations that represents this situation, and then we're also going to figure out what is the price of each type of ticket, which would mean we need to solve the system. So to write the system, we need to look for, there's two variables that we need to figure out. Which are our two variables? And that would be the types of tickets. There's two types of tickets because it says here, what's the price of each type of ticket? So the variables are going to be the variables are going to end up being the tickets here, and then we want to see, okay, what's the the two different things here. We have so we need to figure out two equations from this, and the two equations, they're going to be kind of like these two situations. So it tells you right here something about the adult tickets and the student tickets here, and then it tells you another thing about the adult tickets and the student tickets on this sentence here. So those two sentences, we're going to translate those to two equations. That's definitely the hardest part about this whole thing, is just trying to get those two equations and figure that out. So if you already know that we can use A and even S, sometimes I just use A for the adult tickets, and S is going to be our student tickets. So these are tickets here, so the adult tickets, I should put tickets and tickets. Oops. Okay, so our equations then going to be 64 A's, 64 adult tickets, so 64 A's, and would be plus 132 S's, 132 student tickets. Okay, so the variables are going to represent the price of those. So that's what it's going to represent the price of the ticket. So I should say the dollar amount. So we should say the dollar amount for these tickets. So it's really going to be the dollar amount that we're looking for, because it says what is the price down here. And so we know that the total price over here is going to equal, so if we figure out, okay, 64 times the price of an adult ticket, and then 132 times the price of a student ticket is going to equal 1040. That's our one equation. The other equation talks about the number of tickets, or something about the tickets here. An adult ticket costs twice as much as a student ticket costs. So the adult tickets are twice as much. So if we want to just say it like this, one adult ticket is actually two times of what a student ticket costs. So there's our second equation. I know it's a very simple equation, and that's fine. It's nice and easy to work with. Just that's what it's saying here. The adult ticket costs twice as much as a student ticket. So one adult ticket is equal to basically 2 times a student ticket. So now this is a situation where we can use substitution. We know A equals 2S. We can plug that in up here for our A into this equation. So let's go ahead and do that. So it's going to be 64 times 2S plus 132S is equal to our 1040. And so 64 times 2 is 128S plus the 132S equaling the 1040. So now we're going to add these two together. So it's going to give me, what's that going to be? 260. So 260S when you add these 128 plus 132. And it's going to equal 1040. So now we want to divide by 260. This will tell us what one student ticket costs, in fact. So actually, let's go backwards a minute. I did this one already. So basically there's two things they want us to do. First, they want us to write the system, which I did here. Second thing to do right there is what's the price of each type of ticket. So I'm working on the second part now, figuring out what the student tickets cost. I've already figured out this right here is my system. I wrote my system right there. That's the answer to the first part. And then the second part is what I'm working on now. So when I divide this, let's go ahead and take my calculator out here, 1040 divided by 250, or 260, sorry, it's going to become 4. So $4. Student ticket is worth $4. $4 for a student ticket. So now we're going to take this, plug it back into A, so we could just know that A is going to equal twice that amount. So that's going to be $8 then for an adult ticket. So there's our answer to the second part. What's the price of each ticket? Students are worth $4 and adult tickets $8. All right, so I'm going to have you try one now on your own. This next problem here with the vans, I'm going to have you go ahead and try. So that's this problem with these two different vans. So a business, let's go ahead and read the problem together, and then you can go ahead and pause the video and try to work it out yourself. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. Question, only one question here, what is the cost of each type of van? Now, in order to answer that question, you are going to have to write a system. So it didn't say to do that on this one, but you had to know that you're going to need to write a system of equations to figure out what the cost of each type of van is. So go ahead and pause the video and maybe first just write your system of equations and then check it with what I'm going to do here in a minute. So go ahead and pause the video, write your system, then play it again and check to see if you're right on that system. Okay, so our variables are pretty clear here. We have A and B. We can just use location A, location B for the 2 variables. We have 2 situations, or actually not 2 variables. We don't want to use those as the variables. I'm completely mistaken. Our 2 variables, because we want to know what's the cost of each type of van. So the 2 types of vans, in this case we have a large and a small. So we can use L for the large and S for the small types of vans. Those are going to be our variables. So you first got to figure out what your variables are going to be. I was totally off by thinking that these were going to be our variables. I think maybe that's what you might have thought at first too. So maybe it was a good thing that I kind of got distracted with A and B, because that might be what you would have gone to as, oh, my variables are right there. There's the letters. But that's actually not them. That's actually the 2 equations. Location A is our first equation. So we're going to write an equation for location A. So basically we have location A, location B as our 2 equations here. Okay? I'm going to use L and S. Now if you want to use X and Y, you can. You can assign Y or X to the large ones, Y to the small ones, or whatever you want there. I like using the letters that they come with, though, so it just helps me remember which one's which. So location A, it receives 5 large vans, so 5 L's. And means plus, okay, whenever you see the and, you're going to put plus, 2 small vans, so 2 S's. Okay, for a total cost of, this is our total cost, $235,000. So really, what is L and S representing? It's the cost of these. So remember, these are going to be price. The cost of a large van, the cost of a small van, is what the L and the S are really representing. And equation B now, location B has 2 large vans, so 2 L's, and 3 small ones, so 3 S, and that was $160,000. So there's your 2 equations. You should have checked that. If you got that correct, good. Just keep on going now. Pause the video again, and then go off of those equations. If you didn't get those equations right, then fix it so you have these correct equations, and then pause the video and then solve for L and S and see how much does each van cost. Alright, so hopefully you pause the video and you finish this and you know the answers. You're just going to check them with what I'm doing. This one would be set up for elimination, in fact, so we could eliminate one of these. We're going to have to multiply both of these, because I can't multiply 2 by anything to get a 5, or multiply 3 by anything to get a 2, so that's not going to work. We're going to have to multiply both equations. Let's go ahead and eliminate the S's. So I'm going to need to make this into 6. So they can both become 6. This one's going to be multiplied by 3. This one's going to get multiplied by 2. Now I want them to be opposite signs as well. Right now they're the same sign. So I'm going to go ahead and make this a -2 as I distribute that one into there. So 3 times 5, I know it's going to be 15L. And then we're going to get 6S. And then this times 3, maybe I'll use my calculator for that. So 3 times the 235, 1, 2, 3, whoa, too many zeros. I'm going to go 3 times 235, and just do that first. 705, so it's 705 with 3 zeros after it. 705, 3 zeros. And then this one's going to be negative 4L and minus now 6S, and then 2 times this, that's going to be 32, negative 3,200,000, like that. So 320,000. So now we're going to combine these together. We're going to cancel our 6S's. 15 minus 4, it's 11L. It's equal to, so I'm going to subtract this now. Let's go ahead and get 3 zeros here at the end. 5, let's see, we got 5 minus 0, that's going to be 5. We're going to have a 0 and 2, so I'm going to have to make this into 68 here. So that's a 68. Or sorry, not 68, my bad. 6 there, and this is a 10. What I'm doing here. So cancel out that 0, make that into a 10. That's into a 6 now. So 8 minus 2, that's what I was thinking. It's going to become an 8. It's going to become 8 down there. 6 minus 3 is going to be 3, then there. And then just divide by 11. And so let's go back to our calculator and do that. So 385 divided, I'll do the whole thing here. 385 with 3 zeros divided by 11 is 35,000. So the large van costs $35,000. So that's the large one. Now the small one, we want to go back into one of them. I'm going to just go back to our original second equation, original B. So let's put it over here maybe. I'll do it in blue. So 2L, so 2 times the 35,000 plus 3S is equal to the 160,000. So this is going to be 70,000 then here, plus 3S is equal to 160,000. Subtract 70,000 then from both sides. So 3S is going to equal, that's what, 90,000. So now when I divide by 3, basically 9 divided by 3 is 3. So that's going to be 30,000. So S, put the S over here, is going to be $30,000. So there's our answer for how much each one of those vans cost. The large one's $35,000, the small one's just $30,000. All right, so that concludes this lesson on 2x2 systems. You want to go on and continue with the extra practice for this packet here of this review. And then you should be starting to get ready. We'll be going on to even bigger systems on the next lesson. 3x3 systems will be our next one. All right, I'll see you on that next lesson.